Free body diagrams, part 2 of 2. So in our previous video, part 1, we covered some details about drawing free body diagrams. In this video, part 2, we'll see how those free body diagrams can help us when we come to apply Newton's second law. So we'll do some review of what was in that first video. What is a free body diagram? It's a diagram that shows all the forces that act on an object. And our focus in this video is to see that when we have a free body diagram, that's a huge help when it comes to applying Newton's second law. Newton's second law says add up all the forces as vectors and set it equal to the mass of the object times the object's acceleration. The diagram just shows all those forces and their directions. So it's very easy to add them all up as vectors. We were talking about this example problem in that first video. Small box, box number 1 sits on top of a large box. You lift them up, you're holding them from underneath box 2. And we'll start by considering the situation of everything being at rest, and then we'll apply an acceleration and see how that changes things. So when we drew the free body diagram of box number 1, this is what we arrived at. The gravitational force applied by the Earth on box number 1, the normal force applied by box 2 on box number 1. We're accounting for all the things that apply forces to box number 1. Same thing with box number 2. What interactions does box number 2 have with its surrounding environment? It interacts with the Earth. There's a gravitational force down applied by the Earth. There's a downward normal force applied by box number 1. There's an upward normal force applied by you because you're holding the boxes from underneath box number 2. You can put these together into one system. Okay, you've got the downward force of gravity on the system, the upward normal force applied by you. That gives you the overall free body diagram of the system. Just those two forces, quite simple. When you draw the system's free body diagram, you can consider that to be the sum of the individual free body diagrams, and we talked about that in the first video, and that's pretty much where we left it. Okay, so, right, and we saw how these different forces transfer over to the combined systems free body diagram, and those other two that are struck out in red, you don't have to worry about appearing on the combined system free body diagram because they are internal forces, and by Newton's third law they cancel each other out. Okay, so we will go on from there and say, well, what's the normal force applied by box 2 on box number 1 if the system's at rest? So we're applying Newton's second law. The sum of all the forces add up as vectors on box number 1 is the mass of box 1 times its acceleration. But we know the acceleration is 0. We'll choose an upward direction to be our positive direction. So anything going up is a positive sign, plus Fn, 2 on 1, minus m1g, that's down, so it's negative, equals 0. The 0 comes from the acceleration being 0. So you solve for the normal force applied by 2 on 1, it's equal to m1g in this particular case. Okay. How about box 2? What's the normal force applied by you on box number 2? Well, let's see. We write out Newton's second law. Sum of all the forces added up as vectors applied to box number 2 is the mass of box 2 times its acceleration. Again, we'll take up to be positive. Okay, so the only upward force in the picture is the normal force applied by u on 2, so that goes in with a positive sign, minus the normal force applied by 1 on 2, minus m2g equals 0. Okay, now, from the previous screen, we learned that Fn 2 on 1 is got a magnitude of m1g. By Newton's third law, Fn 1 on 2 must have the same magnitude, so it must also have a magnitude of m1g. Okay, so the normal force applied by u on box number 2 is m1g plus m2g. Note that if you were to calculate this, you would use g as a positive quantity. We've already got its direction built into the equations. So when you put a value in for g, it is a positive value. Okay, how about the normal force applied by u on box 2 if we analyze the system free body diagram? Okay, so this time we get the sum of all the forces acting on the system add up as vectors is the total mass of the system, m1 plus m2, multiplied by its acceleration. Again, up is positive, so we get Fnu on 2 is a positive force minus the downward gravitational force, m1 plus m2g equals 0. Rearrange and solve for that normal force. And you want to check that this is exactly what came out of what we did when we get the free body diagram of the second box. And it is the same result. So that's good. We should get the same result. So Fnu on 2 is, what we said before was m1g plus m2g. That's exactly the same as what we have here, m1 plus m2, all multiplied by g. Okay, so let's change this up so we have an upward acceleration. So you're standing, holding these boxes in an elevator that's accelerating upward. So what happens here is that you're stuck with m1g. The interaction between the Earth and the box doesn't change, but the normal force interaction applied by 2 on 1 can change, and it does. So we write out Newton's second law again, but this time we don't get equals 0 on the right-hand side. We get equals m1a, and we've chosen up to be positive. That's the way the acceleration is. So in this case, the normal force is different from what it was before. It was m1g with no acceleration. Now it is m1g plus a. Okay, second situation, second box. What's your upward normal applied to this second box? Those two forces, both normal forces, change. Now there's an acceleration. So once again, up is positive. We write out the sum of all the forces. We said equals 0 before. That was when the acceleration was 0. Now we have equals m2a. And Fnu on 2 is Fn1 on 2, but we just figured out that Fn 2 on 1 is m1g plus a, so we can replace Fn1 on 2 by m1g plus a here, because of Newton's third law, and we get that result for Fnu on 2. Again, g is a positive quantity. Okay, so that came from here, from the previous screen. Okay, put everything together. Here we go. That force is different now. Up is positive. Fnu on 2 is minus m1g plus m2g is m1 plus m2a. Rearrange, and you get that. It's exactly the same as what we got from the second box's free body diagram.